Hello students, hope you all are doing well. Here in this video, we are going to present you another topic that you find in organic chemistry. It's about the saturation and unsaturation. It's the saturated compounds what we are having in this video to talk about. As well as we are going to focus on alkyl groups. There is another type of groups that you find in organic chemistry, within organic compounds. Okay, let's first find it out. The first topic, saturation, unsaturation. Saturation means the maximum. It has been cut off with that thing, whatever it is. Saturated with what? It matters. So, saturated means the maximum amount of that thing what you are having, focusing on, is there. Unsaturated means you are not having that maximum. You might be having that, not maximum. Let's talk about the satisfaction. When you have the satisfaction maximum, then you are saturated with the satisfaction. If it is, though you are having some amount, much, but not maximum, it is not saturated, still unsaturated. Okay, so here within organic compounds, organic molecules, also you would find similar saturation and unsaturation. Saturated with what? It's the maximum number of hydrogens that you are having. When you are having the maximum number of hydrogen possible to be there with that carbon number is what we call the saturation. If it is not there, the maximum number of hydrogen, but you might have some amount of hydrogen, but not the maximum number of hydrogen there. It's then unsaturated. Let's not be narrowed to hydrogen only. It might be, it's possible to be sometimes a substituent of hydrogen, a derivative of hydrogen. To the position of hydrogen, you could talk about chlorine, fluorine, such halogens as well. Anyway, let's find it out. What is the saturation and what is the unsaturation? Students, you take the organic compound. This is called ethane, the second alkane that you get, with 2 carbon. The maximum number of hydrogen that could ever be is 6. With 1 carbon, it is the very first alkane, it is 4 hydrogen you find maximum being possible to be there with that number of carbon. Then with 2 carbons, when you do not have the maximum possible number of hydrogen there, then it's a moment called unsaturated, not the fullest or maximum amount of hydrogen that it ever could be there. So with 2 carbons in alkanes, you find 6 hydrogen. So in alkenes with 2 carbons, you find 4 hydrogens. When it is an alkyne with 2 carbon, you find 2 hydrogens. Out of them, within these 3, the maximum number of hydrogen you could find there when it is an alkene. So, if we could identify a general thing as when it is an unsaturated compounds, not only sigma bonding, you get pi bondings as well. So, here you have 1 sigma and 2 pi bonds. 1 sigma, 1 pi bond. It is a sigma only between 2 carbons. Between carbon and hydrogen, you get sigma only all the times. So, then when you find the pi bonds within organic compounds, they are unsaturated. For the reason they won't ever get the maximum possible number of hydrogen they could have. Then let's talk about some other situation when it is not just a hydrocarbon, when you have another atom as well. This also belongs to the compounds of saturated. For the reason it does not have any pi bond within the molecule. So, students, this chlorine is considered as a substituent of hydrogen. So it has substituted to the position of hydrogen. Therefore, we do not consider it as an unsaturated one. Okay. Then we could interpret in this manner as well. Saturation and unsaturation. Saturated is when you do not have pi bonds there. Only sigma bonding you get there within the molecule. Unsaturated is when you have pi bonds there. So when you consider those three hydrocarbons, alkanes, alkenes, alkynes, its alkanes belong to the category of saturated. Then alkenes and alkynes, they do not have the maximum number of hydrogen they could ever have. So belong to the category of unsaturated. Okay, that's what it means by the saturation and unsaturation. It's a very simple thing. Later on, we would be seeking for a value, the number of pi bond, for sometimes number of cycles, saying it is the unsaturation number. Let's find that out later on in our future videos. Anyway, then let's go to the next topic. Students, next is alkyl groups. What are the alkyl groups? You just consider a tree with a branch or branches up. Then a branches itself is not considered as a tree, but it's just a part of the tree. Similarly, sometimes you would get this kind of, it's the idea, this kind of a substance. This is a substance itself, it is ethane, so it is not just a part of a molecule. But for sometimes you would get, it's a carbon chain, a molecule, organic molecule, having this kind of part. So when you name, it would be quite not a very kind of, it's not a straight line, it's just a branch, it's just a branch part of the chain. So we call those alkyl groups. When you find this part alone as not representing the whole molecule, but just has attached to the molecule through a bond, so this part is considered as an alkyl group. Here at this context, it's called a methyl group. It's methyl group. So in that manner, you would find sometimes you would find some such parts of CH3, CH2, CH3, CH2, CH2, CH3, such parts within an organic molecule, hydrocarbon, it could be any other organic molecule as well, not representing the compound itself alone, playing the role of just a part of the compound, just a branches of that. So such are referred as alkyl groups. Alkyl group. So when we check for the possible alkyl group, as I have named it here as methyl. So based on the number of carbon you find within an alkyl group, you would add the suffix YL to the carbon number that you find within the alkyl group. When it is one carbon, it is meth in Latin. Eth, prop, but, pent, hex, hept, oct, non, dec. So then your alkyl groups would spread as methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nodyl, decyl. Such kind of alkyl groups you would find. So systematically, when you recognize a part as an alkyl group, you just take the alkane with one carbon, you remove this hydrogen here and you make it attach through this bond to a molecule. So this then would serve as a branch of the molecule. So this is a methyl group. This is an alkyl group. This alkyl group with one carbon is referred as methyl. So for an example, when you have a carbon chain like this, when you get a branch like this with 3 carbon, we could denote it by CH3 as well. So it's a methyl group you have. It's an alkyl group. Okay, let's go for an alkyl group with 2 carbons. Students, when you get the respective alkane, ethane, when you remove one H there and when you make it attach to a molecule as a side chain, it's a side chain. So it's the alkyl group with 2 carbon. It's with the suffix yl. 2 in Latin is eth. It is ethyl. It could be represented by this as well, CH3CH2. It's okay though you give it in the form of C2H5 as well. This is ethyl, the alkyl group. When you go for another alkyl group with 3 carbon in a branch, in a side chain, if you find 3 carbons like this, so it seems like you have removed the edge of propane. So if you get the alkyl group with 3 carbon, it is propyl. Prop is 3 in Latin. With the suffix yl, it is propyl. Could be represented by in the form as CH3, CH2, CH2. But you can't represent in the form as of C3H7. It's not good. It's actually not. It's just possible to represent this only. It's one possibility only. This part, this side chain standing for this. There is another possibility standing for C3H7. That's why it's not that good. Representing this propyl group in that manner. Let me show that. It's students, you will find that C3H7 in this form as well. Here also you have a CH3, and it is this also could serve as an alkyl group, a side chain, a branch. So then it is not considered as this. It's not the same anyway. This is called isopropyl. This is called normal propyl. Normal is N propyl. Normal propyl. This is not that. Normal. Anyway, it's called isopropyl. What is iso? It's not a, it's just a trivial name. Iso is when you have 2 CH3 groups attached on the same carbon, and when you get another H being attached there, this kind of structure is referred as an iso. So when you have only these 3 carbons, it's isopropyl. When you have it in the form as this CH3, 2 CH3 on 1 carbon and 1 H. Then when it continues having other CH as CH2, then if this is the side chain, it is within the side chain you have this iso part. Then it's 4 carbon system. Then it is isobutyl. When you have further another 1 carbon, this is a side chain, but it's having the iso system, iso part. Then it's 1, 2, 3, 4, 5. It's isopentyl. In that manner, it's isohexyl, isoheptyl, isooctyl, isononyl, isodecyl also possible you to have. So anyway, it's just an applied name only, a trivial name only, this iso. Anyway, it's better if you are not mentioning this kind of system in the form as of this, it then could stands for isopropyl as well. This is normal propyl. When you have 4 carbon in a chain, but when this chain is not just the main chain, if it is a side chain, it is then it is then alkyl. It is then alkyl. So this alkyl is 1, 2, 3, 4. It's 4 but with YL, il. It's butyl. It's butyl. So students, when you get an alkane with a certain number of carbon, when you deduct one hydrogen there, you could get an alkyl group. That's why alkyl groups are not compounds themselves. They serve as side chains, just branches of molecules. Those are the alkyl groups. In that manner, you would find a series of alkyl groups having first to 10 carbons as methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl are the first 10 alkyl groups. So then these are few simple things that you would easily understand. Hope it's clear to you. So students, within this video, we talked about the saturated, unsaturated compound based on whether they are having the maximum number of hydrogens. Out of those hydrocarbons, alkanes, alkenes, alkynes, alkanes only were saturated, alkenes and alkynes were unsaturated. Then when you find branches, so within organic molecules, then you could name them as alkyl groups. Methyl, ethyl, propyl, butyl, pentyl, hexyl, heptyl, octyl, nonyl, decyl are the first 10 alkyl groups. Hope those simple things are clear to you. So, if you are going to round up here in this video, willing to meet you in our next video. Okay students, bye.